Hello and welcome to your college and advanced algebra class. This is your instructor Mark J. V. Aquilio, and today we're going to talk about lesson 1.D, Order of Operations Agreement. At the end of this lesson, you'll be able to evaluate exponential expressions using the correct order of operations. In lesson 1.C, we did some simple evaluation of exponential expressions. If you haven't watched that lesson yet, or if you are not present in the live class, you can watch it on YouTube or you can look for it in the class. In this lesson, we're going to do more with evaluating exponential expressions, and that is to use the correct order of operations. Have you ever experienced solving or evaluating an expression and get different answers every time? Or use a calculator and get different answers, results, or values every time? If so, then you probably were not aware of the order of operations that you used. If you evaluate an expression and you begin and proceed differently each time, say you did multiplication first before you did addition, or you solve the expression inside parentheses or grouping symbols last, chances are you'll get different answers too. To deal with this, mathematicians agreed on the order of operations. The rule governing this order is simple and can be used by all to arrive at exactly the same answer. Two people evaluating the same expression using the same order of operations will get the exact answer all the time. The order of operations agreement can be summarized in the acronym PEMDAS, where the letter P stands for parentheses or grouping symbols, E for exponential expressions, MD for multiplication or division, and AS for addition or subtraction. You need to remember before we proceed that MD is placed on the same level and AS on the same level, because that doesn't mean that since M is placed before D, that you should do multiplication first before division or addition first before subtraction. It doesn't go that way. The reason they're placed on the same level is so that you would understand that the rule will be specific in saying that you can perform division first or multiplication first depending on which comes first if you evaluate from left to right. That's why they're placed on the same level. They're grouped together, the M and D and the A and S. And they're written that way, where M precedes D or A precedes S, is because it's easier to read if we do it that way. So the acronym is PEMDAS, and you need to remember the acronym in order for you to easily remember the order of operations. Now, the first one is parentheses or grouping symbols. And this one involves the following. We have the brackets. We used to call the brackets as square brackets in the class, but it's referred more accurately as brackets only. You can say brackets if you want to use these square brackets. Other one is brace, so these are braces. We have parentheses and we have absolute value bars. So before you proceed with evaluating the expression, you need to perform the operations inside the grouping symbols first, whatever is inside. And in evaluating what's inside, you should use the order of operation for steps 1 to 3. And we're going to talk about these steps as we proceed. But when you evaluate inside the brackets, you still proceed with these steps. For instance, in PEMDAS, when you evaluate inside the bracket, or the brace or parentheses, the braces or parentheses, if there are grouped expressions, you begin with the grouped expression again, and then inside that group you begin with the order of operations. Now if inside the parentheses there are no grouped expressions, then you can proceed with the usual step. You proceed with the E, with the exponents, with the MD, with the multiplication, division, and the AS, the addition and subtraction. After you deal with whatever is inside the parentheses, you deal with the outside using the order of operations. You're going to see how it's done using an example here. So we have an example. We have 4 squared times the quantity 5 plus 3 raised to the third power, or cube, times the quantity 8 times 9 plus 2 squared minus 5 squared. According to this step, or this rule, we need to perform the operations inside the grouping symbols first. If you notice, we have two grouped expressions. We have two pairs of parentheses. We have the first one containing 5 plus 3 and the second one containing 8 times 9. So we need to deal with those two first before we proceed. Adding 5 with 3 gives us 8. 8 times 9 gives us 72. So rewriting, we have 4 squared times the quantity 8 cube times 72 plus 2 squared minus 5 squared. After the P, we can proceed with the E, and the first step begins with the E, the exponent. So step 1, for exponential expressions, evaluate exponential expressions. So exponential expressions are 4 squared, we have 8 cubed here, we have 2 squared, and 5 squared. We need to evaluate those. So evaluating, we have 4 squared is 16, 8 cube is 8 times 8, 64 times 8 is 512, 2 squared is 2 times 2, or 4, 5 squared is 5 times 5, or 25. So here, so we've evaluated the exponential expression. The next step is to evaluate multiplication and division. Do multiplication and division as they occur from left to right. So we begin from the left first, and whichever we encounter first, we perform either multiplication or division. In this instance, we only have multiplication. So from left, 16 times 512. So we multiply that first, times 72. So that's it. 589,824 plus 4 minus 25. After you do multiplication or division, you may proceed with addition or subtraction. That's the last step. Do addition and subtraction as they occur from left to right. So looking at it, we have 589,824 plus 4. So we're going to do that first. So it becomes 589,828 minus 25. So only after you've added the 4 will you do the subtraction. And it gives us 589,803. If you followed through the calculation and you have the same exact answer, then you did it correctly. If not, go back, review, rewind, and review and check whether you got the steps correctly. If not, then check which step you did incorrectly and learn from it. Let's have another example here. We have 10 minus 8 squared multiplied to the quantity 23 minus 2 squared plus negative 27 divided by 3 squared. PEMDAS, we have the PEMDAS rule. So the first is parentheses. So we only have 1 here. Inside the parentheses, we have 23 minus 2 squared. So we're going to deal with it first. And since we're dealing with the inside of the parentheses, what's next inside the parentheses is exponents. So we need to do 2 squared first before we can evaluate the inside of the parentheses. So begin inside the parentheses and evaluate 2 squared equals 4. So we have 10 minus 8 squared times 23 minus 4 is 19 plus negative 27 divided by 3 squared. Next, with parentheses is exponents. So we have here 8 squared and 3 squared. We're going to proceed with those two first. 8 squared is 64, 3 squared is 9. Our new expression would be 10 minus 64 times 19 plus negative 27 divided by 9. After the e exponents, we will have MD, that is multiplication and division. We're going to evaluate from left to right. Whichever comes first, we perform either multiplication or division. Here we have 10 minus, so this is not what we're looking for here. This is not our concern. We have 64 times 19. So this is the first encounter that we have. So we need to perform the multiplication here. 64 times 19. Plus, meaning this is not our concern, minus 27 or negative 27 divided by 9. So here again, so we need to perform negative 27 divided by 9 second. So let's proceed. 64 times 19 is 1216. Negative 27 divided by 9 is negative 3. It gives us 10 minus 1216 plus negative 3. Next, we do addition and subtraction, whatever comes first. So we need to perform 10 minus 1216 first before we add with the negative 3. This gives us negative 1209. If you got it correctly, congratulations. If not, review the example and check which part you did wrong so that you can learn from it. Here's another example. We have 8 plus 3 squared multiplied to the quantity 5 cubed minus 2 squared plus 200 divided by 2 squared. First one is we need to deal with whatever is inside the parentheses. And we have 5 cubed minus 2 squared. So we need to, after looking inside the parentheses, we need to use the rest of the rule. That is the PEMDAS, the PEMDAS. Exponents next. So we have 5 cubed is 5 times 5, 25 times 5 is 125. And 2 squared, 4. So we have 8 plus 3 squared times the quantity 125 minus 4 plus 200 divided by 2 squared. Now we can evaluate what's inside the parentheses using the last rule. Let's go back. Inside the parentheses, we don't have P, we don't have parentheses inside. We dealt with the E. The M, the multiplication and division, doesn't exist. Addition, subtraction, we have subtraction, so we need to perform the subtraction inside the parentheses. That's 125 minus 4 or 121. Next, with parentheses, we have E, exponents. So we have 3 squared here, and on the end we have 2 squared. 3 squared is 9, 3 times 3. 2 squared is 4, 2 times 2. Rewriting, we get 8 plus 9 times 121 plus 200 divided by 4. Next, with exponents is MD. So we have, from left to right, 9 times 121. We need to do this first. And then 200 divided by 4, this second. 9 times 121 is 1089. And 200 divided by 4 is 50. Next, with the MD is AS, addition or subtraction. We don't have subtraction here, so we proceed with addition. 8 plus 1089 first, and then we add the 50, giving us 1147. Now, what's the use of order of operations mostly in evaluating in our lesson? Its main use in the context of our preliminary chapter is evaluating variable expression. When we evaluate variable expression, provided that the values of each of the variables are given, we need to use the order of operations agreement in order to come up with a uniform, hence in this context, correct answer. Let's explore first what a variable expression before we proceed with using the order of operations agreement with it. So what's a variable expression? This is an example of what a variable expression looks like. You'd see we have 3x squared minus 4xy plus 5x minus y minus 7. We have a squared variable with an exponent, x squared. We have two different variables, x, y. On the third, we have x only. On the fourth, we have y only. On the last, there is no variable. So what are these? Let's explore this in the next slides. But before we do that, we need to realize first this fact that 1 minus 1 equals 0 can be rewritten as an addition instead of a subtraction, like 1 plus negative 1. Notice that when we insert the addition symbol in the middle, the minus becomes the sign of the next number of 1. So it becomes negative 1. So we can express this expression, this subtraction, in terms of addition. The reason for that is because addition and subtraction are one and the same. Performed subtraction is considered the inverse of addition. So you can express addition in terms of subtraction in terms of addition. Similarly, you can express division in terms of multiplication. For instance, 1 divided by 2 can be expressed as 1 times 1/2. Okay, so realizing that fact, we can rewrite the expression here that we have in the example, instead of subtraction, as all additions. So we can rewrite this as 3x squared plus negative 4xy plus 5x plus negative y plus negative 7, like this one. You can express it in the form of addition. And when you have that, we have addends here. 3x squared is an addend, negative 4xy is an addend, 5x is an addend, negative y is an addend, negative 7 is an addend. These addends, well, you see, the 3x squared, the 4xy, the 5x, the negative y, and the negative 7, these addends are called terms. So how many terms do we have here? We have 1, 2, 3, 4, 5 terms in this expression. And of the terms here, we have 3x squared with a number with a letter, a variable in it. We have negative 4xy, positive 5x, negative y. They have variable combined with a number. We call them the variable terms. How about the negative 7, the remaining term? What do you call that? The negative 7 is called the constant term, or this is one of constant terms. Why? Because if you're gonna think about it, 7 is constant, its value is constant, while if there is a variable or a letter, the value changes or varies depending on the value of the variable. So these are variable terms. Okay, and in the variable terms, we have the numbers 3, we have 4, we have 5. In here, there's a missing number. I hope you realize that whenever we have a variable only, there's a missing number here, but it's implied. So these are called numerical coefficient. How about this missing number? This missing number here in between is 1. Thus, this is negative 1 in here. The 1 is not written. You cannot say 1x because it's implied that an x is only 1x. How about the letters here? We have x squared, xy, x, and y. What do you call them? They're called the variable part. Okay, so the pairs are composed of numerical coefficient, the number, and the variable part, the variable. These are only in variable terms. You can see them in variable. So now that we have explored the parts of an expression and a variable expression, then we can proceed with evaluating a variable expression, provided that the value of the variable is given. Here's an example. Evaluate x cubed minus y cubed divided by x squared plus xy plus y squared. Notice that the expression is in fractional form when x is equal to 2 and y equals -3. Now what happens when we have an expression in a fractional form? Then we would consider that the numerator has parentheses on it and the denominator has parentheses on it as well. So we're going to do numerator first, and then we're going to do the denominator afterward, and then we're going to perform the division last. Does it violate the PEMDAS? No, it doesn't, because there are parentheses on top and parentheses on the bottom. It's implied. It's assumed that the numerator is enclosed in a parenthesis and the denominator is enclosed in a parenthesis. If in doubt, you can rewrite this in the form of a division notation. The quantity x cubed minus y cubed divided by the quantity x squared plus xy plus y squared. So you can rewrite that in a division notation in order for you not to miss out on the PEMDAS. So let's evaluate it, and the first step that we need to do before evaluating variable expression is to plug in the values of x and y in the expression, x being 2, y being -3. Rewriting, instead of variables, we change the variable into numbers. So we get 2 cubed minus, since y is -3, minus the quantity -3 cubed divided by, or all over, 2 squared plus 2 times -3 plus the quantity -3 squared. So we can use now the order of operations agreement on this. Let's begin with the numerator. So we have exponents. So we have 2 cubed, that's 2 times 2 times 2, that's 8. And we have 3 cubed, or -3 cubed. So that's -3 times -3 is +9, times -3 is -27. At the bottom, we have 2 squared, so that's 4. And -3 squared, so that's -3 times -3 equals +9. Using PEMDAS gives us 8 minus -27 all over 4 plus 2 times -3 plus 9. Now we can proceed with the multiplication first. MD, we have 2 times -3 equals -6. And then we can perform the addition and subtraction, giving us like this one, like this in the example here. So we have 8 minus -27 all over 4 plus -6 plus 9. And then we can perform can simplify first. We have negative, negative. It needs to be turned into a positive. And voila, we have 35 divided all over -2 plus 9. We can perform this at the bottom. 9 minus 2 is 7, giving us 35 divided by 7. And now we can perform the division last. This only applies in fractional expressions. You can perform division later or at the end part. Gives us, the answer is 5. Let's have another example. Now this is not fractional. It's not written in a fractional way, and this is a simple one. Try this and pause the video while you're solving. You can proceed with caution if you're done so that you can check the answer. If your answer is wrong, then you can reevaluate. Check which step you did wrongly. So the expression is x, the quantity x plus 2y squared minus 4z, when x equals 3, y equals 3, and z equals -4. And the correct answer is 17. So if you have a different answer, that means you did not follow the steps correctly. Oh, by the way, this is to correct. The value of y is -2. Y is -2, not 3. Okay, so proceed. And that's it. Answer is 17. That's it. And I hope we could talk more in the live class so that we can have more examples. Thank you for watching. Thank you for listening. Have a good day.